is here. Omar Bias, the NASA Launch Director from the Kennedy Space Center. Vernon Thorpe, the Program Manager for NASA Missions from the United Launch Alliance. Dr. Jim Fanson, the Kepler Project Manager from the Jet Propulsion Laboratory. John Trelsch, the Kepler Program Manager for Ball Aerospace. And Lieutenant Greg Strong, the U.S. Air Force Launch Weather Officer from the 45th Weather Squadron at Cape Canaveral. And now, Patty Boyd. Patty.
Thank you, George. It's a pleasure to be able to talk to you today about the science of Kepler, NASA's first dedicated exoplanets space mission. Exoplanets is the study of planets that are orbiting stars around stars other than our sun. It's a very new, exciting, and rapidly growing field of astrophysics. The first planet discovered outside our solar system was confirmed in 1995. And today, only 14 years later, we now know of many more planets outside of our solar system than inside of our solar system. Over 340 exoplanets. And the list continues to grow at an exciting pace. So far, the planets that have been discovered to date are largely gas giants, similar to Jupiter, and they orbit their parent stars at distances about the orbit of Mercury or closer in. They're very close to their planet stars. They're nothing at all like our solar system, which we know so well, and we've yet to discover a true analog to Earth. Kepler is NASA's first mission capable of detecting Earth-sized planets in the habitable zones of stars like the Sun. The habitable zone is a region around a star where the conditions are right for liquid water to exist on the surface. We believe that liquid water is essential to life on Earth. Kepler is essentially a planet sifter for Earths. It's been specially designed to be able to answer the question, how commonly will we find planets the size of Earth in the habitable zones of stars like the Sun? The answer to that question could fundamentally shift our picture of our place in the universe. For centuries, people have looked up at the sky and been mesmerized by the sheer number of stars we see out there on a clear, cloudless night. The Sun is just one of over 100 billion stars in the galaxy, and it's natural to ask how many of those stars have planets around them, like Earth. Could I have the first graphic, please? We're looking at a region of the sky that's familiar to many people. It's where the Milky Way passes through some of the summer constellations, and you can see this region of the sky virtually every clear night in the summer. Superimposed on this image is virtually the footprint of the Kepler instrument. Once Kepler launches and begins science operations, it will stare at that region of the sky continuously, carefully monitoring over 100,000 stars, looking for tiny dimmings that will happen when a planet passes in front of the star and blocks out just a little bit of the light. Not all planets are in our line of sight, so we have to look at a lot of stars. And a planet like Earth passing in front of the Sun would happen only once a year. So we have to look continuously for a long time in order to detect transits of planets like the Earth. These are the considerations that really drive the unique Kepler mission design. Kepler was chosen in 2001 as part of NASA's Discovery program. The science principal investigator is Bill Barucki at NASA's Ames Research Center, and Bill has led the science team from the beginning when Kepler was just a dream 25 years ago, through the proposal phases, and now he is set to lead the science team as they sift through Kepler data, looking for hints of planets, and then following these up with large telescopes on the ground. Bill and his team will talk to you after this briefing about the science that they're very excited to do with Kepler. The science office is at NASA Ames. Mission operations will also take place at NASA Ames. Kepler is managed by NASA's Jet Propulsion Laboratory through commissioning. The instrument and the spacecraft were built by Ball Aerospace. The entire Kepler team has worked tirelessly to take Kepler's planet hunting journey from a dream to a reality. It's a unique mission, it's an impressive instrument, and it is now ready to fly. And the community is all very excited for launch on Friday, and we're even more excited and anxious to get the first Kepler data and to really begin to answer this profound question for the first time. Are Earths common or rare in our galaxy?
Thank you, Patty. And now to our NASA Launch Director, Omar Baez. Omar?
Thank you, George. Thank you for all coming, and I'm going to present the vehicle buildup and tomorrow's countdown. If we could roll a short tape that we have on the buildup. We started building up the rocket for Kepler, the Delta II, back in the October time frame. We were initially trying to put up the STSS booster, which this is the first stage of that mission. This is the 9 solid motors that are around the booster that are being put up there. It's a 3-stage mission. Here's the second stage. That's the brain of the outfit. It's got the flight computer, the RIFCA, which controls all the pointing of this rocket. It also controls the separation events. On top of this, we'll have the third stage, and basically the second stage points the third stage at where it needs to go. It starts a spin up of the spin table, which is basically a lazy Susan with rockets attached to it. Spins it up to about 55 RPMs, and gyroscopically shoots it in the direction that it needs to go for the target interface point where Kepler needs to go. That stack there in the can is the spin table, the third stage, the PAF, and the Kepler spacecraft. That protective cover is there to transport it from Astrotech over to Pad 17B. There you see as they lower it onto the second stage, and there's the fairing going in around Kepler. It's the 10L fairing, 10 foot wide, long stretch. That protects Kepler on its ascent up. We'll release that during the second stage portion of the flight. And it's a real beauty to see that thing come together. The spacecraft arrived at Astrotech on January 6th. We did our lock sleep checks on the booster back on January 19th. We mated the spin table, the third stage, to the Kepler spacecraft in mid-February. On February 18th, we canned up the spacecraft and took it out, transported it to the pad the next day. Unfortunately, we weren't able to hoist. It was a little bit too windy, and we had to drive back to seek shelter in the discus processing facility for 2 days until the wind subsided and the temperatures cooperated with us. But we were finally able to get it up there. We performed our flight program verification on the 23rd, and everything checked out wonderfully. We installed the fairing on the 26th of February. We held our flight readiness review this past Monday with the decision to load the second stage fuel and oxidizer Tuesday, which we did successfully. We also performed our mission dress rehearsal this past Tuesday to exercise the management team. We connected the launch vehicle ordnance yesterday, and we held our launch readiness review this morning, and that was very successful, and we're ready to fly tomorrow. Talking about tomorrow's count, at 10 a.m. we will get our weather brief. We should have the MST rolled back off of the vehicle around 2 in the afternoon. Around 5:30, we will start our terminal count, and we'll start pressurizing the helium and nitrogen bottles. About 8 o'clock that night, tomorrow night, we'll load the RP1 on the first stage. That's the kerosene. And start our LOX load about 9 p.m. The LOX load takes us about 45 minutes. We will have a couple of holds tomorrow. One's a 10-minute and 57-second hold at T-minus 20 minutes. And then we will hold, excuse me, that was 10 minutes and 57 seconds at T-minus 4. And I'll give my final go at 3 minutes, and hopefully we'll hit it right on the money at 10:49:57 tomorrow. 2 windows tomorrow,